Hello and welcome to this video on linear functions. Today we're going to review some of the properties of linear functions and work out some problems that deal with linear functions. Linear functions are equations that are modeled by y equals mx plus b. You might have seen this before. Sometimes they use the letter a instead of m for the value in front of the x. And you also see if it's a function notation, they are going to replace y with f of x or some other function name. So f of x equals mx plus b is the function value. They can use some other function here. They may not even use the value of x. They may use another variable. Now, in this function or equation, the rate of change or the slope is this m value. So m value or a value here, this value right here is your slope in the function. So right here is the slope in this function, this is the slope in this function. You can identify it by it's next to the variable. Okay, the variable itself, whatever variable you use, it's going to be next to that. And the b value, the other value in the equation, is going to be the initial value where the equation starts. Now when we write models for linear functions, we usually use that because we want to predict something, if they have some kind of prediction of what may happen in the future if we're using this model. So we use a model or a function to do that prediction, and we'll do more of these things later on in the next video. In this video, I'm going to do a couple examples, or a few examples. Here's my first one. It says the town's population is growing linearly. In 2005, the population was 69,000, and it's growing at a rate of 2,500 people per year. Now, we can identify these, and it says, in this case, write a function p of t. So this is my y value. And this is going to be my x value in the equation because it gives me different variables than our model here. It's in this problem, it's giving me two numbers. It's telling me a rate growing. So this is going to be your m value. And it's telling me what we started out at. In 2005, we started out at this value. So this is going to be my b value in the equation. Now, since in this model that we did here, it's y equals 2,500 x plus 69,000. But since they're using different variables here, we're going to have to change it to match what they want. They want p of t instead of y. And we still have 2,500 is our growth. And then instead of x, they want t. And 69,000 stays the same. So this is our model for this problem. It's telling us how much we're starting out at and how much we're growing by. So when we're looking at a problem like that, you want to see if they identify what your growth is, or rate of change, the rate of change of the function. In this case, we're growing. So the rate of change is 2,500, so it says people per year. That's telling me it's a rate of change per year. So we're changing with the rate of years here. Okay, let's do the second example with this one. Type. It says a boat is 100 miles away from the marina, sailing directly toward it at 10 miles per hour. Write an equation for the distance of the boat from the marina after t hours. Okay, so we have two values here. We have 100 miles and we have 10 miles per hour. Okay, so both of those values, one's going to be your rate of change and one's going to be your initial value. So in this case, 100 miles, that's going to be a initial value. So our initial value here, so this is our b value in the problem, or initial value. Okay, and then this one's going to be our rate of change. Okay, we have to make sure that we're writing the equation, okay, t is our variable. Okay, it doesn't give you what we're going to write here with f of t, so we're just going to use p of t. So we're going to just use f of t here for the function notation. We could also use y if you want, or distance. We might use the letter d for distance, d of t maybe. You can pick that out here since they didn't tell you what to use. So it says we're saying directly we want to write an equation for the distance of the boat from the marina. So it's going to get closer to the marina, right? We're going to start at 100 and we're going to decrease by 10. So in this case it's going to be a subtraction problem, not our rate of change is going to be negative because we're getting closer. So in this case, if we wrote d of t here, our initial value is going to be 100, and we're decreasing our distance because they're directly by 10 t's. Okay, so sometimes when we see this problem, we write it also in the reverse way so that you could start off with the initial value and what's happening to it also. So sometimes it's written 100 minus 10t. Sometimes it makes more sense to think of it that way, since we started out at 100 and we decrease by 10 miles every hour, and we want to find the distance. So in 1 hour we're going to be 90. 2 hours will be at 80. So we want to know the distance, so it's decreasing, so it's going to be minus. Whereas in this problem we are increasing population, so it's going to be plus initial value. Alright, so in the next part you need to know that increasing functions have positive slope and decreasing functions have negative slope. So this one decreases, so the slope was negative, whereas this one up here increases, so the slope is positive. So if you see an equation written either in function notation or y notation, y equals 3x minus 2, that's going to be increasing because of the 3. It's positive. But if you see y equals negative 5x plus 7, we're going to have a negative slope here, so that's going to be decreasing. Okay, now to calculate the slopes we have another equation. Now in this picture you can see that there's a slope here. The slope is going to be considered the rise over the run, so we're going to take some value on the graph. We're going to figure out its rise, and then we're going to calculate its run, and we're going to write that ratio as our slope. Now if we have points, our equation for points is y2 minus y1 over x2 minus x1 for points x1, y1, and x2, y2. Now it doesn't matter which order you put them in on the equation, it should give you the same value. You just have to start with the same point twice. So if you start with this point twice, you can subtract this way, then you're going to do that both times. You're not going to start with this x and then this y. You want to start with this x and then that y next to it when you do the subtraction. Alright, so that's how we calculate slope. That's the other big formula besides the y equals mx plus b. So those are the main things to remember here. This formula here and what it stands for, and this formula for slope here and what it stands for. It's a change in y. That's what this thing stands for. Change in y over change in x. This little delta stands for the word change. Okay, let's do an example of using this formula. So I have my points here, and I'm going to find the slope of this equation. So in this problem, we're going to just subtract. We're going to find the slope. So we would take the y values right here, and we would subtract them. We take the x values and we subtract them. Now we can start with either one. I'm going to show both of these and tell you that it is going to be the same. So if we go right to left, we go 5 minus 9, those are the y values, or if we go left to right, we go 9 minus 5. It just depends on which one's x1, y1, and which one's x2, y2. So you can subtract in either order, but in this case, if we start with the 5 here on the fraction, then we have to start with the negative 2 on the bottom. Negative 2 minus 1. And if we start with the 9, the second y, then we have to start with the 1 here on the bottom. 1 minus negative 2. So we should come up with the same answer. If not, our formula would not work out. So in this case, it wouldn't be generalized. We have to have two formulas. Okay, so in this case, 5 minus 9 is negative 4. And negative 2 minus 1 is negative 3. Since those are both negative, I can write that as 4/3. And that's how I would write the slope, since it doesn't reduce. This one, if I subtract, I get 4 to begin with. These two signs change because they're next to each other. So then I have 3 in the denominator, and we get the same answer, 4/3 for both slopes. Doing the formula either way. Alright, you may also have to find the slope from a graph of an equation. So if in the graph they want you to find the slope, we're going to be doing this right here. We're going to be identifying the rise over run. So in an equation, what you would do here is you'd find some points that are on integers values. So if I were to go 4, it has a value up here, so I could use that point to do my calculations. If I go to 3, it doesn't really have. I'd have to guess maybe here what that is. 2, I have to guess what that is. It's not exact. 1 is a guess. 2 looks like it crosses here. Negative 1, you guess in between, guess in between, guess in between. Okay, so we have 3 points. Here's a point down here that I could use. I have 3 points that I could use here. So I could either go from here and rise over run. I could go from rise over run here, or I could go from here and run all the way out to this point. So in any one of those would work. You want to use the closest two so you don't have to reduce. So I'm going to check this right here. We're going to check these values here. So rising here is, we go up 1, 2, 3, so the rise is 3. We go to the right 1, 2, 3, 4, so my slope here is 3 over 4, rise over run. Now if the equation is going down, then I always go from from left to right here, just as we were reading. So I always pick my point on the left. I don't go backwards like this and then down. I would always go take a point on the left and move to the right. So that's my general philosophy, is go from left to right as we normally would read. Okay, on this problem my points are, that's not a point. Okay, so at negative 1 it does have a point right here. It goes through here. At 1 it goes through here. So it does have 3 points on this one as well. Okay, so I'm going to take a point on the left. So here my rise is actually down. I'm going down here. 1, 2, 3. So my rise here is negative 3. My run, I'm going to the right again, so that's going to be 1 there. So my slope is negative 3 over 1, which is negative 3. We can divide that. This one we don't reduce. This one we can reduce. Okay, so that's the slope of the function. Now they're also going to ask you later on to write the equation. So let's just do that while we're here. They're going to say later on in this section, write an equation with this thing. So we have to go to the next step on this, which is to find the initial value. Alright, so we have the slope, we have the equation y equals mx plus b. We know this value now because we've done that part. We then have to find the initial value. Well, the initial value is where it crosses the y-axis. So this is the y-intercept. Okay, so the initial value is the y-intercept. In this case, the intercept is right here. So this is 2, 0, 2 is the intercept here, and in this one the intercept is 0, 1. So the intercept is 1 here, the intercept is 2 here. We should be able to write the equation because we have these two numbers now. So the equation for this graph is y equals 3/4 x plus 2. The equation for this graph over here is y equals negative 3x plus 1. So you're going to look for the y-intercept. If they later on, the first part of the thing, they're just going to ask you for the slope. But later on, they're in the same section, they're going to ask you to find the equation. So I thought we'd just do that while we're here. Okay. Moving on to another example, they're going to ask you to go back and just compute slope. So this, we were computing slope up here, right? We did the equation. We did a graph to find the slope, but we're going to go back and compute a slope from a problem. So from a problem here, we have a slope problem. We're going to have a starting value, and the starting value is going to be like an ordered pair here. 1958, comma 2,113,000. And in 1991, that's another point, comma 2,099,800. Okay, and see, I didn't want to use those parentheses there, or commas, because it makes it look strange here. So we're going to use, we don't want to use commas on the second one. 0,99800. Okay. So these are our points. It says compute the slope and make a statement about the population rate. Okay. So what we would do here is we just do our equation for the slope. So we would take, let's go in order here, reverse order. So 2,099,800 minus 21,13,000 over, since we started with this one, we go 1991 minus 1958. Alright, so we need to do the subtractions. Alright, so I'm going to get my calculator out here to do that. So the first problem in the subtraction, when we subtract those two numbers, we get negative 13200. Okay, so it does go down. Population did decrease here. And then 1991 from 1958 is going to be 33 years. Okay, so we need to divide that to find the slope. So that would be 400, negative 400. Okay, so then it says make a statement about the population rate per people. So we're basically, this is saying we just divided the population by years. So this is a rate that's in people. This is people up here, and this is years down here. So the statement would be to say that the population decreases at a rate of 400 people per year. And here we don't need to use a negative sign because we said it decreases. Okay? So that would be my statement about the population rate per year. And it gives you the thing saying it wants people per year. So it's decreasing at 400 people every year because that's what we found out. When we reduced it, we would reduce it and get 1 on the bottom. So that would be per year. Okay, moving on to the next example. It says a phone company charges for a service. This time they're using function notation. So they have, instead of y, they wrote this function. They've reversed it, so they've given you the initial value first and the rate of change second. Okay, so that's what they're asking for in this problem. What's the monthly charge? And it's asking you to interpret the range and the initial value. So in this case, they reversed this on you here. The initial value would be 26. And the rate of change would be 0.04. Now, it's N is the number of minutes talked, then we're charging in dollars. So this is $26 as our initial value, and $0.04, so this would be 4 cents. So this would represent, your bill would represent your initial value, initial charge is $26, so that's what they're going to charge you per month no matter what you do. And for every minute talked, you're going to add 4 cents. So charged on top of that, um, 4 cents per minute. Okay, so that's what that means there. And they wrote it in the fashion where they give you the initial value first and then the change here. So they reversed it on you. Okay, the last thing in this section we're going to do is look at tables to determine whether they're linear. So it wants to know if they're linear. So basically what we're looking at is the slope and seeing if it's the same as we travel up here. So in this case, we're just looking at these differences versus these differences. Okay, so the difference here is positive 2, positive 2, positive 2. The difference here is negative 25. Let's see. I think this is also 25. Yep, 25. And that's 25. So this rate, this slope on this one is negative 25 over 2. So it's always the same, so this is linear. If they change at a different rate, then it's not going to be linear. So it also says find a linear model. So in this problem, we have the slope and we have the initial value. The initial value is where it starts at 0. So the initial value is here. So our equation here, if we just use y equals, is y equals, oh, well, we can't here because it says g of x. So that's going to be not y equals, that's going to be g of x equals negative 25 over 2 x plus 6. And we can reduce that to negative 12.5 if you want to write this as g of x equals negative 12.5 if you want to divide and write it that way. That's also correct. Okay. Okay, let's look at this one. This one is similar. We get 2 here. It's going 2 there. Here from 2 to 4. From 4 to 8, it goes up 4. and from 8 to 10 it goes up 2. Over here we go up 10, here we go up 20, and here we go up 10. So these are the same because we're dividing by the number across from it. So here we have 10 over 2 as the first slope, we have 20 over 4 as the second slope, and we have 10 over 2 for the third one. These all reduce down to the same number, which is 5. So this is linear also. They were trying to trick you by changing these values, but when they did that, they changed it appropriately so that you get the same ratio. So its equation for this one is going to be h of x equals 5x, and they didn't give us an initial value here, so we're going to have to find that. So what we would do here, what I would do is just say, well, let's figure this out from the chart. We're going 2 up, so if we go 2 down to 0, so if we go another 2 here, then we would go another 10 here, so that would mean this value is 3. So I would then put 3 here. So just using the chart to help me get back to 0, I would initially just do that same ratio here, 10 here on this side and 2 here on this side to get back to 0, so that I have a point that I can use for my y-intercept. And I would do that again on this example if I have to. Let's just check to see if it's the same first. So these are 2, all of them. This one goes up 20. This one goes up 20. This one goes up 20. So this is also linear because it's the same all the time. It's just always 20 over 2, which is 10. All right, we're going to have to go backwards on this one as well. To get to 0, we have to go up 2 more, and this one we have to go down 20 more, so that's going to be negative 24 here. Okay, so my function here is going to be f of x equals 10x minus 24. Alright, now let's look at this one and see if it is also linear. So this is 2, this is 4, this is 2. Let's check these ratios. This is 25. This one is 75. This one is, let's check. Let's just make sure I did that right. 106 divided by r subtract 31. Yep. And this one is 25, I believe. 25, and that, yes, is 31. Okay, so let's check this again. The ratios here are 25. Since they're not the same like this one, we got 25 over 2, 75 over 4, and 25 over 2. The question is are these two equal? That's the question. So if you divide 75 by 4, you get 18. So this one's going to be 18.75, and if you divide 25 by 2, you get 12.5. So these are not equal, so this is not linear. So we don't write an equation because it's not the same ratio each time. Alright, and that finishes this video for linear functions.